shows what our sensing system sees when en route to a delivery. It's really hard for humans to see that there's a moving object on the horizon. Anybody see it? Now let me show you the same video, but with an overlay of our computer vision algorithm. The algorithm detects the paraglider almost immediately. This is one of the vision tasks that computers are way better at than humans. After safely arriving over the target, the drone shifts to vertical descent for delivery. We need a small area around the delivery location that's clear of people, animals, objects, ground anomalies. We determine this using a stereo vision-based depth map, and in parallel, our neural network-based algorithms, which are trained to detect people and animals from above. Let's take a look at this technology in action. We see a few different things here: the down-looking sensors view, the delivery area with obstacles, and output from the detection algorithms. On the left side, you see the network-based detections on both thermal and gray level images. And on the right side, the stereo vision-based detections. Once the customer gets too close, he's detected before the drone gets close to the ground. The drone recognizes that it's not safe, so it doesn't descend any further. Customers are notified when the drone is approaching in our system, so we don't expect to see people in the delivery zone very often, but that doesn't matter. We collect huge amounts of data and run millions of simulations to verify that any situation is covered. So let's talk about wires. A customer's yard may have clotheslines, telephone lines, electrical wires. Wire detection is one of the hardest challenges for low-altitude flights. Through the use of a few novel and proprietary computer vision algorithms, we've overcome this challenge. Now as our drone descends into the customer's yard, it recognizes the wire and safely avoids it. We use geometrical computer vision to develop this technology, and while I can't get into the details today, there's a unique physical property specific to wires that can be detected using computer vision. Here's a quick clip of this. Can you see the thin clothesline in this backyard? Our computer vision algorithm can. It's another example of our system detecting the hazard well in advance with no incident. From paragliders, power lines, to the corgi in the backyard, the brain of the drone has safety cover. Now we've designed many drones since the inception of Prime Air, in fact more than 24. As promised, before I finish up, I wanted to leave you all with a little glimpse of Amazon's future. This is our latest drone. It's the most elegant and sophisticated system out there today. So what are the advancements? This is a hybrid aircraft. It can do vertical takeoffs and landings like a helicopter. And it's efficient and aerodynamic like an airplane in forward flight. It also very easily transitions between the two modes. So from vertical mode for takeoff to forward flight in airplane mode and back to vertical mode. It's a completely new shape. It's fully shrouded for safety. The shrouds are also the wings, which make it efficient in forward flight. Unique design provides 6 degrees of freedom as opposed to the standard 4 in a quadcopter. This makes the vehicle more stable and capable of operating in more gusty wind conditions. The propellers are novel as well. They have been optimized to minimize intrusive high-frequency sounds. Because just because you want your package delivered quickly doesn't mean you want you or your neighbors to hear it coming. See for yourself in this new flight video. Here's the transition to forward flight. Super smooth. The chase drone, by the way, had trouble staying up with this bird. Now the vertical transition from the horizontal to vertical. For a safe landing. You're going to see this new drone delivering packages to customers in months. I want to thank the team for their incredible work on this new drone design. And I want to thank all of you for giving us this time and your attention. The future is right around the corner, and I couldn't be more excited. Thank you.